Nice. Oh, yeah, it's working. Cool. How are you doing? Woo. Waiting for my slides to appear. Hopefully. Yeah. Before we start, so yes, indeed, yeah, I'm an Nginx, and I'm indeed here based in Croatia, but I kept my very nice Russian accent in English, so yeah, enjoy it. What we're going to speak today, and I think after the last presentation, you're not going to have a nap. It's healthy, but not right now. What we're going to speak is more about nuts and bolts. Where we doing it, what we're doing with our Kubernetes, how to put traffic in. So this is what we natively do in Nginx. And then we will speaking about the topic, like what we should do. Of course, it's what Nginx is probably famous for, and what you know Nginx for is its performance. That is kind of cool, but we're not going to talk about Nginx specifics, what is inside. We're going to talk about what is it for you, how you can use it, how you can build real production architecture. This is what is our topic today for the next 20-25 minutes. And it's really easy to start. Our diagram. No, I'm joking. We're not going to focus on everything what is here, but these parts are important. So how you do the code, meaning how you developing it, deploying it, how you run it on your Kubernetes infrastructure, and then what is the security stack or optimization stack, whatever. What we're going to talk is this thing, is data plane. How to get requests or the packet to our apps, to our workloads. This is what we're basically focusing. For ones of you who are not that familiar with Kubernetes infrastructure, let's get the common base. So whatever you do the container that is running your code that is going to bring you millions, it's called pod in infrastructure. So we can scale them. We can have a lot of them. This is what basically Kubernetes is doing. It's managing our pods. Then if they are similar, we can combine them to the things called service. So it represents single entry point of the service, how we run it, and get the request into. And then there is a slight problem that we're going to speak today, how to get data from the user to this very service. And there is a lot of things in between. It's load balancing, because it's the production side, as a high-performance side, we might have a few nodes, right? There is a thing called ingress that we focus a lot. The ingress is the rule how to put the traffic into the Kubernetes environment, or how you can actually rule it. Control plane is important too. So then we're speaking about the control plane. What I'm usually referring to is first of all, is a Kubernetes cluster. It can grow many computer nodes, right? And the Kubernetes cluster has what? Nodes. They can be master nodes. How many master nodes can be in a cluster? For the Nginx t-shirt? Just one, huh? You're not running high-performance sites. Huh? Minimum. What is the maximum? There is a maximum for the master nodes. OK, you have time. And the worker nodes, that basically has no maximum for that. Then we have a namespaces, so the projects, right? Ones who runs OpenShift, right? It's the same. Then we can split role between the different roles, different functions, how you can run your projects, and then we deploy our code into the deployments. That can create different services. So one can be blue, another can be red, then the green, yellow, or you name it, usually by the functions what they are basically doing, like Daniel in the previous slide. So this is basically what we got in the terms of code, in the terms of if I want to put my application into the Kubernetes, right? The problem starts, then I want to put it to the outside world. So I have a few nodes that running and ready to get all the data from the sleepers to the real world. They all start getting, okay, what is my sleep rate, or I don't know, what is my I don't know, data from the banking application or whatever. And here we realize that my node is actually just a server that needs to be wired somewhere. And what should I do? I need to have some load balancer. I need to have any technology that knows how my application actually works. Where is the blue server? Where is the light blue, the green, or anyone else? And here the problem starts. It works until you have one master node. Then it works. Because you can run things manually, more or less. The load is not so high. The moment you start to grow, and guys, the problem is that growth is coming suddenly, unexpectedly, like a winter. This is what ingress controller is intended to be. So this is a part of the infrastructure that sits between your nice Kubernetes environment and the outside world. It knows how the traffic should come to the nodes, but it also knows where your application is. And it also knows, it's giving you the control how to get the traffic into. Should it be distributed locally, evenly, like on this slide, or you should have different parts of application, you should have canary deployment, whatever, the ingress controller should take care. What I forgot to mention as the functions, it's pretty much. So we can divide them between so-called traffic management things, load balancer, reverse proxy, canary deployment, Berlin deployment, rate limiting, you name it. Security functions, whatever you want to put as offload your authentication, make a, I don't know, web application firewall. It can be done in this very place of infrastructure. And monitoring is important. We need to know what is actually going on. It should not be just a piece of code. It should provide some feedback. What are the problems we're trying to avoid? There are a few of them that we see quite often that our users are coming with. So first of all, for sure, it's the performance. It's important to understand that things actually are running bad. Because to identify it in the right moment, to see what is going on, to see where is the bottleneck, I don't know, in the network, in my cluster, it is important and to get data. Then security. Security is the common problem. What I'm talking about, like, I don't know, basic web application firewalling. SF5 is our big guys, our mother company. They're doing the great web application firewall, by the way. On their events, we show that we just put a new dummy application on a conference like that. In a half a day, by the noon, it's a plenty of scanners, exploit verification engines, and everything that is simply living outside of internet and scanning all the new domain registration and everything. So the put new service outside is extremely important to put in a secure way. And finally is organizational part. So how to manage. Manage is important. You can build your stack of the traffic in many different ways. It's probably thousands of ways how to do it. In a way to do it in the most scalable, reliable, and, excuse me, but maybe popular way that is the most people are doing is giving ability for your infrastructure to go in the future, and ability for you to troubleshoot and understand what is going on, right? This is where we come to what I'm talking about. It's Nginx Ingress Controller. Nginx Ingress Controller is basically Nginx web server or reverse proxy that runs under control of the Kubernetes API. We, in a tight integration with Kubernetes, we know how it works, and basically, whatever new service appeared, its configuration appeared here as well. It says Nginx Protect. This is this security engine. I'll have a couple of words about it a little bit later. So What we focus on with Nginx ingress controller, four key factors that we focusing on building this ingress controller for you. So first is the performance. Performance is quite natural for us, and Nginx, this is what we found of. Remember, Nginx was built after Apache ran to the limit of the concurrent connections. So this is what we naturally doing quite good. Second is automation. This should not be standalone or outstanding reverse proxy that you should have an Nginx guy how to configure Nginx and the Kubernetes guy how to configure Kubernetes. You should run it simultaneously in one process, in a one pipeline if you want. Second thing is quite important for us is what is going on. I will show the Grafana dashboard a little bit later. You should see what is the patterns of the traffic, what is the error rate, what is your latency, and many other parameters up to more than 100 metrics that we provide from the Nginx ingress controller. And you can put the web application firewall engine on top. Sorry, guys, this is behind the paywall, but still it's there. Important to mention, there is several Nginx ingress controllers out there. Board is sometimes created to confuse us. But the main difference is here. So there is one, use Nginx as a proxy, but made, we call by Kubernetes community. How to identify that? You usually get it from the Kubernetes repo. Then you get Kubernetes ingress controller for Kubernetes. If you want version from Nginx, you get it from Nginx repo. They are quite different. So they are same on the data plane, but they different in the way they configured. And I will show a couple of examples later. They actually both quite a high performance rate. So all the numbers, they're probably way too much for your applications and way too much for your deployments are ready to be scaled once you deployed the tiny instance of the Nginx ingress controller. You can go up to tens gigabit per second, hundreds thousands requests per second. This is all there. Difference starts at the high performance. The moment we go closer to our peak load, we see that community ingress controller start to introduce a little bit of latency. So this is the difference are that we hard-coded this automation into our piece of code, and we see that latency is not increased that much. Same about some commercial distribution. OpenShift, they got router built in. You don't need to bringing your own ingress controller. Router is built in for you. This is extremely good, but the behavior on high performance load is also not that great comparing to the Nginx ingress controller. Good news here that whatever Kubernetes distribution you are using, whether it's a managed one, commercial one, or the vanilla Kubernetes, you guys can mix different ingress controllers. They can work basically simultaneously. They read, if you want same ingress API, that you can publish to the one or another ingress controller. So you can use different technologies simultaneously. This is good. Speaking about the security, web security or web firewall or application security, same name or same technology, is technology that analyzes each and every request that consists out of the headers, body, URLs, and everything. Does it has any signs of attack? Like, should I really think that this is kind of SQL injection, cross-site scripting, or whatever? So it's basically done on the signature analysis and the thousands of signatures that each request should pass through. And then we put this technology of web application firewall into Nginx ingress controller. We see that analysis of the request, making the structure of the request and each piece of it gone through these thousands of the signature is basically it's not that far from the one without it. So introducing the security is not breaking the things. Usually it does. This is a common way of thinking. Introducing the security will break something. Here, it is not break because the performance is great. And the second, because you controlling the security and not security guys. Huh? This is also cool. Good. Moving on. So, controlling the things. The way we usually recommend to do is to collect all your metrics in Prometheus from the Nginx in order to have single pile of the information. And then we provide some nice dashboards for Grafana, like this one here. What is given to you? You constantly have the understanding what is going on. Anybody like to go through the logs of the containers? Nobody, right? So this is basically what we do for you for operations to see what is going on. Now, after we know that Nginx ingress controller is what? Is the best ingress controller there, how to put it, how to deploy it. Start is easy. So you can deploy it as simple as a deployment. This is how the thing's called. So whatever you need, number of replicas, whatever you need, you think that is sufficient. You can monitor the load with the metrics that I showed. This is it. Then you could put it just as a node port up there, and magic is happening. Then you don't care about the infrastructure there, how the network is doing, what is it. Nginx ingress controller is your point of creating rules for the network at this point. You're growing, and you think, I probably might need more performance. Then suggestion is dedicate the nodes for the traffic management. So worker node and the production Kubernetes cluster can be quite a big number. Dedicate couple, why couple? For the redundancy, for the infrastructure node. Then all this performance that was on the graphs before with the number of CPUs and the gigabits and the thousands of the requests is yours in this setup. This is quite reliable. Or if you want easy and the most relaxed setup, and you don't want to think a lot about what the nodes types are, there is a daemon set. Daemon set is the way to deploy each piece of software on every node, regardless of the its role. So then, whatever to any port with the wire, to any socket traffic comes, you got the same behavior. And for example, if the purple service is needed here and the packet has arrived here, it's going to be perfectly rerouted here without any problem. It's actually true for any and the two previous topologies, but it's important that here you scale your performance as much nodes you got. So basically, whatever you got more compute power, you got more networking power. This is probably the easiest way. What is in the conclusion? What is the message I'm trying to bring to you? Then it is nothing wrong to use whatever you use today for the getting traffic into. It is actually quite good for the start. This is why most of the managed Kubernetes distributions are done. This is why we started using technologies. And actually, most of based still on Nginx, but this doesn't matter. What we're targeting with our ingress controller is then you're getting bigger. Then you got more tasks to do, meaning the controlling the data, controlling the traffic. You got more people that doing different tasks. You got dedicated networking. You got dedicated DevOps. You got team looking on the reverse proxy rules. So this is probably what technology that designed to be to satisfy these kind of needs. One of the example, single deployment, single daemon set that we discussed at the last topology can work simultaneously with different namespaces. So we just create for what namespace, whether it's a front end or the back end or something else, we want to create our rule, and you define your rule where the traffic should go to which services in your Kubernetes cluster. Few things are quite important on this single slide, on this single picture. First of all, is what the hell is that? Alex, you were talking about Nginx, and this is virtual server. Or not Nginx, Ingress, and this is virtual server. Ingress is a Kubernetes API specification that is created initially for the reverse proxy routing, but it's quite basic. In order to extend and give more functionality, like a rate limiting, like a canary deployment, different technologies are approaching different way. With Nginx, we're also doing these annotations to Ingress that you can use, and use Nginx sleepless of the configuration. But we also recommend to use our custom resources. This is a virtual server route, policies. I will have a word about it. So custom resources allowing you to have more closer to native Nginx configuration, and same time understand what the things are doing. Second thing, this is example of the traffic routing. Why it's important? It's important because you taking in the control what you do with the traffic for your services. You're not calling, I don't know, DevOps guy, networking guy, hey, for this URL, I need you, please reroute it on a very specific destination. No, it is your now. This is what primary role of the ingress controller actually is. So then we speak about these custom resource definitions that we have. It's a framework of them, mainly consists of the virtual server. So it's entry point of our traffic, how we would like to it behave. We can have a route that can be under control of the different team. This is quite important, that for the some project can have a dedicated API that they allow to move. And we have some policies for the additional functions, whatever it's mutual TLS, rate limiting, authentication, access control, you name it. You can have either the native API or the snippets of the Nginx configuration that you're moving from the standalone deployment to the right one. What is the point of that? Point of it is that we can split the roles. You can split the role between infrastructure team, application manager, and development, what they're doing and what is their control, or the security guys. What is their control, what they are doing, how the policies are work. And you quickly identify whom to blame if application is not working. This is the most important point, right? So the role-based access control and your organizational processes that you can develop, you're not limited to technology. This is what we taken into consideration along with the performance, along with all the data. This is actually going along with what Kubernetes guys are thinking. Usually, many years ago, Ingress was introduced as a specification of the basic traffic routing into the Kubernetes. Now we're talking about Gateway API. Gateway API is a Ingress 2.0, if you want. Basically, idea of having different configuration objects Kubernetes-wide to provide the same services. But you see, the Kubernetes is coming to the same idea. We came a few years back, so there is a gateway that is more dealing with traffic. There is a route that is creating rules of the traffic management, and there is finally the service that is doing the service, the most important part. So Gateway API version .0 is released. Nginx Kubernetes Gateway, so it's a version of the Ingress controller for the Gateway API, is also released. It's on a GitHub. You can try it. You can play with it to create your Kubernetes cluster as a truly next generation one, at least from the data plane, and be ready for any load it might suddenly come. Then you guys become successful with your project. This is it from me. I think we have a couple of minutes for questions, if anybody. Woohoo! So the Brave ones with the questions can get the T-shirt with Nginx. Yeah. What exactly the problem is? Okay. What is the opinion of commercializing Kubernetes? Yeah, absolutely. So, question was very politically correct. What is our opinion on the commercializing Kubernetes? But really is Nginx going to stay open source? Answer is yes, Nginx is going to stay open source, and we developing this program. Then F5 acquired Nginx. We tried to make some enterprise grade, the many paid features. We see that they are not really welcome by community. We're going more with open source. Same time, we commercial company. We need to feed our developers. So for example, if you're going the production grade, we're offering you support like from Nginx. Not Nginx Plus, not additional features. We're offering you just support to solving your problems with your open source deployment. Large or X large? Oh, sorry. That's it, guys? Thank you. I'll come to you, OK? Oh, OK, let's, we have a... Come again? Yes, 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 yes.
Use this config map explicitly. I cannot just put it like any other rewrite rule within Nginx.
Yeah. So that's a very good question. So question was about, you haven't heard the beginning. Usually we talk about HTTP, right? So it's like layer 7. We are kind of capable of for layer 4, getting layer 4 traffic into the Nginx, and the colleague over there have the problem configuring that this has to be separate config map and things like that. Unfortunately, with Nginx, we were more focusing on HTTP data. The guys from the F5 doing the big IP, they have a great solution bringing the whole, even including UDP data, into the Kubernetes cluster. This is where we're focusing. So there is a bit kind of networking and application part. OK, guys, looks like this is it. Thank you very much.